Dear students, today we will discuss on dimensions, dimensional analysis and applications of dimensional analysis. You all know that dimension is a very common term in our day-to-day life. Okay, we say that this is a 3D view. Some of the people say this is a 3D film. So this board is two-dimensional. So dimension term is actually a common term in our day-to-day life. Now let us see how it is used in physics actually. So when we say two-dimensional, we mean two fundamental physical quantities. When we say three-dimensional, we mean there are three physical quantities in that physical quantity. Now see the definition of dimension. The definition is like this. It is the power raised to fundamental physical quantities in the expression of a physical quantity. In the expression of a physical quantity. You see, mainly when we say dimensions, we refers to the powers, we refers to the values, we refers to the numbers. Numbers to that fundamental physical quantities in the expression of a physical quantity. Let us see this physical quantity area. When we write area, we write its formula like this: length into breadth. So area is a physical quantity which is length into breadth. Now when I will find out its dimensions, first I will express it. First I will write its dimensional formula. That means I will go for the dimensional formula of area. Then I have to find out the dimensional formula of length. So length is given by this L1, and I have to go for the dimensional formula of breadth. Length, breadth, height, radius, diameter, these are all similar physical quantities. So though they are looking different, so their dimensions are same. So breadth will have also dimension L1. So ultimately area will have a dimension L2. Actually this writing is called dimensional formula of area, and it comes out to be L2. This 2 is actually dimension. 2 is dimension of L in area. This is like this. Actually length is a fundamental physical quantity. We have already discussed that there are 7 fundamental physical quantities like length, mass, time, temperature, then ampere means electric current, then candela luminous intensity, then mole MOL. 7 fundamental physical quantities. So when we will write dimension for any physical quantity, we will actually take the help of these 7 fundamental physical quantities. Most often we will be taking this L, M, T, K and A. These two will be very rarely used. So now see, suppose I will find out the dimensional formula of velocity. When I go for velocity, you see the velocity is given by this formula, displacement by time. Velocity is displacement by time. This is actually the formula. But dimensional formula means I will have to write it like this within the square bracket. Then displacement will be L because this is some sort of length. Time will be T, and ultimately we will get LT minus 1. So the dimensional formula of displacement is LT minus 1. Okay, similarly when I will find out acceleration is equal to velocity by time. It is velocity by time. So the dimensional formula of acceleration the dimensional formula of acceleration will be like this. So this will be L t minus 1 by t, that is equal to L t minus 2. L t minus 2. Similarly, if I will find out force, you see force is equal to mass into acceleration. So this is actually formula. Then when I will go for its dimensional formula, the dimensional formula will be like this. This mass will be m, means and acceleration we have already calculated, L t minus 2. So it will be m1 L1 t minus 2. So in this way we can find out the dimensional formula. Also we can find out the dimensions. You see here 1 comma 1 comma minus 2 is the dimensions of mass, length, time in force. Okay, so now let us go to another term. Let us say we will find out for work. Okay, so work, we know work is given by the formula work equal to force into displacement. So when we will find out its dimensional formula, it will be like this. This is the dimensional formula force, which we have already calculated. Then this displacement will be L. So it will be m L2 t minus 2. So in this way, we can find out dimensional formula of a number of physical quantities that is given in our book or in the syllabus. So you have to only remember the formula of that physical quantity. Then by just knowing, by expressing it in terms of the fundamental physical quantities, we can write out the down the dimensional formula of any physical quantity. Now let us see what are the applications of this. Actually in our course there are two applications. So the applications are like this. The very first one is that checking the correctness of a relation. Checking the correctness of a relation. The second one is deriving a new formula from the given information. So these are actually two major applications of dimensional analysis, though some other applications may be there. So now I will discuss the very first one. The very first one is checking the correctness of a relation. So to actually apply this, we have to go for the principle. There is a principle that is followed here. That principle is called principle of homogeneity. So this principle says that in a correct relation, all the terms in it will have same dimensions. That means only similar physical quantities can be added. Means when I will add, I can add a length with a length. When I will add, I can add a time with a time. When I will subtract also, I can do the subtraction between two similar quantities only. Now you see, suppose we are given a equation like this, that S equal to ut plus half at square. We are told to verify this equation. So by using dimensional analysis, we can verify this. You see, this equation has three terms. Let us find out the dimensional formula of first term. So this will be this. And the second term will have dimensional formula like this. U is L, t minus 1, and t is t, so it will be again L. Similarly, the third term will have a dimension like this. You see, this is half is a number having no dimensions. A means L, t minus 2, then t square is t2, so this will be L. So all the terms in this relation have same dimensions. So this formula is dimensionally correct. Here you keep one thing in mind, that if a formula is actually correct, if it is proved from other things that the formula is correct, it will be dimensionally correct. But if any formula is dimensionally correct, it may be actually correct or not. Suppose I will write here s equal to 2ut plus 3at square. You can also verify that this is dimensionally correct, because this 3 will have no dimensions, 2 will have no dimensions, but that formula is not actually correct. Now let us go to the second application. The second application is like this. This is actually deriving a new relation, from the given information, You see, suppose we are given that a body is moving in a circular path, and its radius is r, the mass of the body is m, it is, let us say, moving with a velocity v. We are told that the centripetal force Fc depends on radius, mass and velocity. So now we are asked to find out expression for Fc. So this particular question or this sort of question we can solve by using dimensional analysis. What we will do here, we will write it like this. You see, first we will write that centripetal force is Fc, that depends on mass, that depends on velocity, that depends on radius. This is proportionality sign. We don't know actually to what power it depends. So let it be A, let it be B, let it be C. So A, B, C are constants, and they do not have any dimensions. So these are called non-dimensional constants. These are the constants. So if we combine, we will get Fc to be equal to m to the power a, v to the power b, r to the power c. And if I equate, I will get some constant m to the power a, v to the power b, r to the power c. Now you see, I assume that this formula is correct. Once I assume this, then I have to find out the dimensions of left side, also the dimension of right side. This is ml t minus 2, the left side, and right side will be like this. So k is actually a constant, it has no dimension. So this will be equal to m to the power a, v means l t minus 1 to the power b, r means radius, so l to the power c. So if I combine, I will get m to the power a, l to the power b plus c, t to the power minus b. You see, right side we have this, left side we have this. Now if we equate the powers of the fundamental physical quantities, so we will get a to be equal to 1 and b plus c to be equal to 1 minus b to be equal to minus 2. Minus b equal to minus 2, b plus c equal to 1, and so a is already calculated. From this we will get b to be equal to 2, and if I put the value of b here, so I will get c to be equal to 1 minus b, that is 1 minus 2, that is minus 1. Now once we know these three values, we can write the formula for f. The formula for f is like this: Fc equal to some constant m to the power a, that is 1, v to the power b, that is 2, r to the power c, that is minus 1. So this is k mv square by r. So when you will actually learn fourth chapter, you will know that the centripetal force is given by a formula Fc equal to mv square by r. But here we have calculated Fc equal to k mv square by r. That means in this method we cannot actually determine the constant, dimensionless constant, but otherwise we can determine on what factors this physical quantity depends. So if you know the value of k, then put it, otherwise leave it like this. So here we know that k will be equal to 1, so our Fc will be equal to mv square by r. In this way, you solve other questions linked with this. Thank you.